Welcome to the lair of the Batty Boffin.
Hi there Batty fans, speed, distance and time again, this time looking at acceleration. Now in earlier videos we've looked a little bit at acceleration. We've either used this formula triangle where we have the change in velocity. Velocity and speed are interchangeable when there's no directions involved, and for these everybody who's going in a straight line kind of carries on going in the same direction, so we can use speed and velocity interchangeably at the moment because there's no directions involved. So V for velocity or S for speed. You can use either at the moment. We've either used this formula triangle with delta velocity, the change in velocity, acceleration times time, or we've used this version of it here where U is the initial velocity, V is the final velocity, and A and T are the time, as before. Now, here we've got a situation for you to calculate. I've got a cat who, like most cats, is slightly mad about laser pointers. And one day she was walking along, just, skulking around looking for somewhere warm to sleep, as cats do, at 1 metre per second. I waggled a laser light and she accelerated. And 2 seconds later, her velocity was 5 metres per second. I'd like to calculate her acceleration, please. So you've got U and V, which are what you're going to put in here. If you prefer to use the formula triangle, you can use those to work out the change in velocity, delta V. Okay, so either by that method or by that method, could you have a go at working that out, please? Right, let's have a look at those. I'll do both methods. Starting off with the V equals U plus AT. V, in my case, is 5, equals U, the initial velocity, which is 1, plus A, which I'm trying to find, so I'll leave that as A, times by T, the time, which is 2. Okay, and now we've just got a little bit of algebra to solve here. Taking away 1 from either side leaves us with 4 equals A times 2. Gosh, I think we can probably see the answer to that there. Acceleration equals 2, and then we need the units. 2 metres per second squared. 2 metres per second. That means my cat changed her velocity by 2 metres per second each second. And that's right, because she started at 1. 2 seconds later she'd be at 3. Sorry, 1 second later she'd be at 3, and a second after that she'd be at 5. So 1, 3, 5. She's changing her velocity by 2 metres per second each second. Okay, I'm going to do it by this method now. I'll use blue for this. For this, we want to have an acceleration. So we need delta V over T. So acceleration equals delta V over T. Delta V, the change in acceleration, sorry, the change in velocity, is the difference between these two. That's 4. Over the time, which is 2. That again, dead easy, and it gives us 2 metres per second squared. Okay? Oh, incidentally, you may sometimes see this unit written as 2 metres per second with a -2 up there. Okay, and you might think, what's all going on there? How can you have a negative in a power? Don't worry about it too much. There are Batty Boffin maths videos that explain negative powers and things, but just for the moment, know that a negative power means it's on the bottom of the fraction. So there it is, metres divided by seconds squared. Okay, so if you see it like that, same thing as that. All right, so that's the first one. I'm going to wipe down the board, be back in a minute for another one to have a go at. See you in a minute. Right, here's one that doesn't involve my skulking cat. Well, it kind of does, but not in the acceleration bit. You're driving a car, and you're driving a car at kind of a bit more than 30 miles an hour, but for your delectation and delight, I've changed that 30 miles an hour into metres per second just to make it easier so that the units all match up. And we've got 15 metres per second is a kind of a car driving speed. If you imagine 15 metres, it's kind of like, the width of a house or something like that, and you can do that in a second. So, yeah, that sounds about right. Anyway, you're driving a car at 15 metres per second, that's your velocity. Actually, I ought to call that U, shouldn't I, because it's your initial velocity. There we go. And my cat runs out in front of you, as cats do. So you slam the brakes on. You apply the brakes for 3 seconds, that's the duration, and at that point your car decelerates So we've actually got an acceleration of -4. Yes, an acceleration with a negative number means you're slowing down. So your acceleration is -4 meters per second. That's not an equivalence sign, as an equals there. Okay, so you've got an acceleration of -4 meters per second squared, an initial velocity of 15 meters per second, and a time of 3. So off you go with that. Either method you prefer, I'll do both when we come back. Right, here we go. Using the v equals u plus at, v is what we need to find, the final velocity. U is 15 plus a is -4 and t is 3. Okay, that one's pretty simple there, isn't it? So v equals 15 plus -12. If you're not sure about negatives, check out some of the Batty Boffin maths videos where we cover that. 15 plus -12, v equals 3 meters per second. So after you've applied the brakes for 3 seconds, you're going at 3 meters per second. Okay, now I'm going to do it by the formula triangle down there. We need to know, now we actually need to know the final velocity, which isn't in there, but that has got change in velocity. So we're going to find change in velocity and then kind of do some bits with it. So change in velocity is a times t. Delta v equals a times t, which in our case is -4 times by 3, which is -12, which means your change in velocity is -12. So our first velocity is 15 plus the -12 leaves you with, amazingly, 3 again, meters per second. So I used the formula triangle to find the change in velocity. Please note, -12 is not the answer, okay? -12 is the change in velocity, not your actual velocity. So once we know it changes by going down by 12, we can take our initial velocity, go down by 12 and end up with a 3. Okay, happy with how that works? That's great. In the next videos, we're going to be looking at some graphs involving speed and time and velocity time graphs and distance time graphs and things like that. Okay, I'll see you in the next time. Bye-bye.
Mwahaha!